In this section, we're going to learn how to read a graph and what kind of information we can extract from a graph. All right, so part A is asking us to find h of -1. This refers to the graph. Now, the graph, this jagged line over here, it represents the function h of x. Now, h of x is the same thing as y, right? So remember that that's important. We can say h of x, or it's the same thing as y. So this blue shape over here, that represents the graph of our h of x. What part A is asking us is find h of -1. Now, what does that mean? What do you guys remember from evaluating a function? This can be interpreted as what? This basically means when x is -1, what is y? That's basically what this problem is asking, because this over here, that information, that is basically the y value when x happens to be -1. So h of -1 is basically saying, okay, when x is -1, find the value of y. So we're going to look at the graph for that. So where is x equals to -1? Well, here is my x-axis, right? So where is x -1? Here is my x equals to -1 right here. Well, when x equals to -1, what is the value of y that corresponds to the point on the graph that we're interested in? Well, here is the point on the graph that corresponds to to x equals to -1. So when x is -1, what is the value of y on that graph? Well, the value of y is 2, because that point over there that we're looking for, let me go ahead and highlight that point. This point over here, that point there, that has the coordinate of -1, 2, right? So basically this says, okay, when x is -1, what is the value of y that corresponds to the point on the graph that belongs to x equals to -1? And of course, the y value is 2. So then that means we can answer part A that h of -1 is 2. This is the same thing as the point on the graph -1, 2. Let's look at the part B. Part B is asking us to find h of 2. h of 2 basically means when x equals to 2, what is y? So again, we're going to look at our graph. So we're looking for x equals to 2. So where is my x? There's my x-axis, and here's x equals to 2. So when x equals to 2, what is my graph doing? Or what value does my function take? Well, it takes the value of 1, because x equals to 2 is paired up with y value of 1 to create this point on the graph. So when x is 2, the output value is 1. So the answer there is 1. So h, not f. So h of 2 is 1, which is the same thing as the point on the graph 2, 1. The last bit is asking us for h of 5. Again, when x is 5, what is y? So here is my x equals to 5. Oh, but then if we're looking for a graph, where is a point on the graph that belongs to x equals to 5? Well, there's an open empty circle here, meaning we don't have a graph at x equals to 5, meaning my function is undefined at that x. So for x equals to 5, I don't have a function at all. So h of 5 is actually undefined. So h of 5 is undefined. We can now do it backwards. So notice for part D, we are given the y value, right? We're given the y value because remember h of x, remember that h of x, that's the same thing as the y value. So we are given y equals to 3. So when y equals to 3, what is x? Right? That's what we're asked. So it's backwards than what we did in the previous one. So then in this case, we're not looking for what x is first. We're looking for, okay, where is y equals to 3? And then when we found y equals to 3, look at the graph to see which part of the graph, what x is it that creates a point on the graph. So let's go ahead and look at it. So where's y equals to 3? Well, here is my y-axis, right? And where's y equals to 3? It's right here. When y equals to 3, do I have any pieces of the graph at y equals to 3? Well, there it is. That's a piece of the graph that corresponds to y equals to 3. So the question is, okay, what is this point where y equals to 3? What kind of x was able to give us that point? Well, the x that gave us that point is negative 4. So let me go ahead and highlight that a little bit. So when y equals to 3, that corresponds to this point over here. And this point happens to have the coordinate minus 4 comma 3, which means for my y value to be 3, well, what was the x that created that y value? Well, that x was negative 4. So then to answer our question, when h of x is 3, the only x that could have given that y value, or that h of x, is x equals to negative 4. So for what value of x is h of x equals to 3? Well, that answer is negative 4. Let's look at part E. Part E is asking us to evaluate h of 3. H of 3 means, again, when x is 3, what is the entire function doing? So this one means when x is 3, right, because that's the number inside, what is the entire function doing? Or in other words, what is y? So again, we're going to come back to finding the x's. Let's see, x is 3 right here. So the question is, when x is 3, what is the function doing? Well, the function attains a value of 1. Or in other words, when x is 3, the corresponding y value on the graph is 1. So our answer is h of 3 is 1. For part F, for what values of x is h of x 0? Well, the question what the question is asking us is, okay, look for where the function equals to 0. Or in other words, where is y equals to 0? Well, here is my y-axis. Where is my y0? Right here. Okay, so when y is 0, do I have any points on the graph that belong to y equals to 0? I do. I actually have 2 of them. One right here and one right here. Another way that you can think about it is think about the points where the y coordinate is 0. So here are 2 coordinate points. One right here, which is negative 3 comma 0. And then you also have one right here, which is 4 comma 0. So that's 2 different that's 2 different points where your y coordinate is 0. So then to come back to the question is asking, okay, for which axis was your y 0? Well, for x equals to negative 3, of course, right here, and then for x equals to 4. For both of these x's, my function happened to be 0. So then the answer is in here is for x equals to negative 3 and for x equals to 4. The domain of a function, remember, it's all the x's that were used to create this function. So to read the domain of a function, always read from left to right, sort of in this direction. So from the left, think about it. What is the smallest number of x that was used in the creation of this function? Well, notice that this arrow over here, that's going to keep going infinitely up and to the left, which means that you're going to have x's over here that are really, really small that have been used to create that graph. So negative infinity has been used to create this graph, right? Or the numbers approaching negative infinity. As we keep going and increasing our x's, all of these x's have been used to create the graph, right? All of this up until here. But as we come closer to 5, we notice something interesting. The actual number 5 has not been used to create the graph, because is there a piece of the graph at x equals to 5? There is not, because this is an open circle. What about x equals to 6? Is there any piece of the graph that belongs to x equals to 6? There isn't, right? There's no graph because it stops over here. So all of the x's that were used to create the graph are 5 and below. In fact, the 5, right, we get really, really close to the 5, like 4.999, but not the actual number 5. So then the domain of this function is going to be everything below 5. So negative infinity to 5, and not even including 5, because that one is an open circle. To figure out what the range is, we look up and down. In fact, we'll go from down all the way up. So we look at what is the smallest values of y that have been used to create this graph. Well, these numbers, let's say negative 4, for example, there is no graph available at y equals to negative 4. In fact, there is no graph available at y equals to negative 2. The lowest value of y that might start having a graph is here near negative 1, because notice that near negative 1, we start having a little bit of the graph already pop up. And then the rest of the y values, they all have a graph that they can correspond to. So everything all the way to positive infinity is going to have a graph, because remember, this part is going to keep going up, up, and to the left forever. So it looks like we have nothing here, nothing here, nothing here. The lowest possible y value that this graph starts to use is -1. But it's not even including -1, right? Because it's an open circle. It just gets really, really close to -1. So the way that we write that is going to be, we start at -1, but we don't include it. But then we take everything above that. To figure out where the function is increasing or decreasing, read the graph from left to right and see what is the value of the function doing as you move from left to right. So as I move from left to right, even though this arrow points up, the reason why this arrow points up is to tell us that this arrow goes on infinitely. It doesn't tell us the direction of the graph. So this arrow doesn't mean that the graph is increasing here. It only means that the graph keeps going there infinitely. Now, how do I tell if it's increasing or decreasing? Well, as my x's start increasing towards the right, notice that my y values keep dropping. They keep dropping and dropping and dropping until they get to the number 3. -3. But then as I move my x's from -3 to -1, my y values start increasing all the way to 2. And then again, as I move my x's from -1 to 2, my y values start dropping again to 1. So to tell if the function is increasing and decreasing where, always read from left to right and pay attention to what your y values are doing as you move from left to right. So it looks like over here the function is decreasing, then it's increasing, decreasing, stays constant, right here, stays constant from 2 to 3, and then it starts decreasing again until we have this undefined point over there. So then over what intervals is the function increasing? Well, we've got this point over here where the function is increasing, and that's the only part where the function is increasing. So let's go ahead and write that. When you write where the function is increasing, you only pay attention to the x values. So the function is increasing between -3 and -1. So the function is decreasing between -3 and -1, and that's it. That's the only interval where the function is increasing. Let's look at the next part. Over what intervals is the function decreasing? Well, it's decreasing here, here, and here. Notice that this over here, that's constant, so it does not decrease there. So let's go ahead and write it over here. Now here, the function is decreasing, be careful, from -infinity, right, all the way to -3. So the function is decreasing from -infinity to -3. Then it's also decreasing again from where? From here to here. Be careful, you're already only reading x values. So from -1 to 2, so it's decreasing again from -1 to 2, and then again from 3 to 5. So we've got 3 different intervals over which the function is increasing. We commonly write them with a comma in between.